Hello, Algebra 2. Today we are looking at the second day of section 2.7, which is still working with linear quadratic systems. However, today we're going to start talking about inequalities. So as we move ahead, we are going to solve a linear quadratic system of inequalities. Okay, so you can see that it looks very similar to yesterday as we look at this system. However, instead of an equal sign here, it's an inequality symbol. You might recall that in order to graph inequalities, anytime you see a less than or greater than symbol, you're going to use dotted lines. Anytime it's less than or equal to or greater than or equal to, it's a solid line. Okay, so when we go to graph these, we are going to graph them by hand because that's the solution. The solution is actually the graph itself. Okay, and so we have to follow 3 steps. The first step is to plot points for the graph. The second point was to decide if solid or dotted. And the third step is to use a test point to shade. Last but not least, the solution is the overlap shaded part. Okay, so those are the 4 steps we're going to go through. So you'll notice that my first inequality is quadratic. I'm going to just think about it as an equation first. You could keep the inequality symbol, but it just gets confusing. And so in order to graph this, for these problems, you really just need 2 points because then you can find a third by using symmetry. So we're going to keep it simple. The 1 point, when it's in standard form like this, that is quick and easy to find, remember, is the y-intercept. That's when x is 0. And remember, that's where if I plug 0 in here and 0 in here, those 2 things just go away. So my y-intercept is just the point 0, negative 10. So by looking at a problem in standard form, I can quickly and easily find the y-intercept. The other point we learned how to find back in section 2, given standard form, is the vertex, which is hk. And this is where we had to use the little mini equation. H is negative b over 2a. So in the problem, I figure out that a is the negative 2, b is the 12. So opposite of b is negative 12 over 2 times negative 2. Negative 12 over negative 4 gives me positive 3. Okay, so my vertex, the x component is positive 3. And then remember to find k. Because we know the x, we plug it back in to find the y. Okay, so it's going to be y equals negative 2 times 3 squared plus 12 times 3 minus 10. And ignore that. Remember we talked about back in section 2 again that we can just type all of that into our equation, or into our calculator, I mean, and I believe I got y equals 8. Which means, so I guess that's the k. So my ordered pair for the vertex is 3, 8. Okay, so I can go ahead and start graphing that. Make a grid. Again, I plot a point at 3, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 3, 8. The other point that this one had was 0, negative 10, so that's way down here. And now remember, technically this has a line of symmetry, so if I went 1, 2, 3 to the left at negative 10, I would go 3 to the right at negative 10, and that's my other point. Okay, so I finished step 1 for my quadratic. That one takes a little bit longer, but that's okay. Now I'm at number 2. I need to decide if it's solid or dotted. Since it's just less than, I'm going to draw a dotted parabola. A little more curve through there. And now we're going to use a test point to shade. So this is the piece it's the same, but it looks different because we're using a quadratic. Again, we've already graphed the linear inequalities. If it's a quadratic inequality, we're still going to use a test point. And if it's in standard form especially, I'm usually still going to stick with my favorite 0, 0 as long as it doesn't fall on the curve, and it doesn't. So what that means is now I take the original. So now I have to think about it as an inequality. So again, y is less than negative 2x squared plus 12x minus 10. I'm going to plug in 0 for the y and 0 for all the x's. I'd have to show all this work. If you knew these were 0 already, you just say, is 0 less than negative 10? So you're asking yourself, is that true? And no, it's not. That means that this point is not a solution, which means I'm not going to shade over 0, 0. Now, the only difference with the parabola is with the line, we said if it's not, then you shade on the other side of the line. The parabola, however, is a little bit different because with the parabola, we either have outside the parabola or inside. So since this x falls outside the parabola and it's not a solution, that means I would shade inside the parabola. Those are all the solutions. Okay, so that's the one big difference with quadratics versus linear. It's inside the parabola. If I got yes, you would shade not only over here, but all the way around the outside. Okay, so that's my quadratic. Let me change colors to graph my linear one. So I'm going to do the work for the linear up here. I have 4x plus y. Again, I'm going to think about it as an equals right now. In order to say equals, all I would have to do is subtract 4x. I could have used y-intercepts as well, but this is going to be just negative 4x plus 4. Okay, so in slope-intercept form, I'm plotting my points. My y-intercept is 4, 1, 2, 3, 4. And my slope is negative 4 over 1. So from there, I'm going to go down 4 over 1. Now, technically, I only need 2 points to plot a line. We are going for general sketches, so we can stop there because we're not finding points of intersection. Again, the graph itself will be my solution. Okay, so I plotted 2 points. That's what I need for a line. For parabolas, you need 3. Now I decide if it's solid or dotted. Go back to the original. It's just a greater than, so it's dotted once again. And last but not least, I need to use a test point to shade. I can again see that 0, 0 is not on the line, so I plug in 0. I get is 0. Oh, now I have to switch to the inequality. Sorry, we better go back. So I had 4x plus y is greater than 4. I plug in 0. Well, the nice thing about when you plug in 0 when it's in this form, all this is 0. So is 0 greater than 4? And I get no. So once again, I'm not going to shade over the x. I'm going to shade away from it, which is over here. But again, don't forget, the solution is where they overlap. So once I've done all my shading for both graphs, now I have to pay close attention and go back and see where, in my case, I see purple and blue. And I remember that I shaded to the right of the line kind of and inside the parabola. So it's everything that falls to the right of the line and inside the parabola. So this right here is my answer. Now, just a reminder that when you do these on Pearson, you must graph them on paper first, because in Pearson, you would graph both the quadratic and the line. Make sure to change it to solid by clicking on the, or dotted by clicking on the dotted line icon after you do it. But it only allows you to shade one region. So you must do all this in the end, and then you would click on the paint bucket and just click in this portion of the graph, and that's how you get that shaded. Okay, let's try another one. I want you to try this one on your own. Okay, so pause the video and see what you get. Okay, so I'm gonna draw my grid over here. Hopefully you took the quadratic and you should have gotten, so for y equals x squared plus 6x minus 12, you should have had a y-intercept at 0, negative 12. And then the vertex you should have found would have been at a negative 3, negative 21. Okay, so you should go back 3, down 21. So we'll just draw it in down here. Okay, and then we also had the vertex or the y-intercept at 0, negative 12, which that is again 1, 2, 3 to the right, 1, 2, 3 to the left at negative 12. Okay, solid or dotted, it's greater than, so you should have done dotted, just like this. And then finally, when you plugged in 0, you would have said is 0 greater than negative 12? Yes, it is. So 0 falls inside that parabola again. So I would have shaded inside. For the line, when you converted it, you would have gotten y So if I take the whole thing though, so 3x minus y is greater than or equal to negative 8. One quick thing, if you decided to keep it the inequality, get here and divide by a negative. Don't forget with inequalities, you have to flip that inequality. Okay, so 3x plus 8. Okay, so I'm going to switch colors so it's easier to see. So plus 8 we would say is up here. I would go up 3, right 1, but just as a tip, that would be off my graph in Pearson. I can also go down 3, back 1. Okay, either way, this time it's greater than or equal to. So you should have had a solid line through those points. And now finally, if I use this and I can still plug in 0, 0, I would get is 0 less than or equal to 8? And yes, it is. Or I could have used the original 3x minus y is greater than or equal to negative 8, and 0 is greater than or equal to negative 8. So either way, I get yes. You could use the original or the other. So this is a solution, which means for blue, I would shade down. Last but not least, remember to find where they overlap, and it's inside the parabola and below the line. Now, just as a reminder, what this means is that any point that falls within this shaded region, or technically on the line between these two things, not on the curve though, because that's dotted, any point in that region would work in this system. I could plug any point in those into both those inequalities, and I would get the same answer. All right, now that we've done some stuff by hand, it's actually a really good review of section 2, graphing parabolas in quadratic form by hand. Now we're going to go back to our graphing calculator, and we are going to use that to solve a system of equations, but it starts as a linear, or as an equation. Okay, so in this case, we're going to solve the equation, but we're going to do that by writing it as a linear quadratic system. Okay, so if you ever get something really ugly like this problem, x squared plus 9x minus 5 equals 4 minus 3x, and you have your graphing calculator available, what you're allowed to do is to take each side of that equation and write it as x squared plus 9x minus 5. That's going to be in my y1 menu. And in my y2 menu, I'm going to type in 4 minus 3x. Okay, so I'm allowed to graph both of those in my graphing calculator. So you graph each side of the equation, and then we're going to find the point of intersection. Okay, so I'm going to leave here and find my graphing calculator. I should have it pulled up. I do here. Okay, so first I was doing some other stuff. So in order to get my settings back to normal on the graph, remember you go zoom and number 6, zoom standard. Okay, so now my grid's going to be okay. I have to delete my other equations. And now I type in what we just had. So I had x squared plus 9x minus 5. That was my first one. And my second one was 4 minus 3x. Okay, so the nice thing about using the graphing calculator, as long as I understand the graph, one side of the equation under y1, the other one under y2, now I can hit the graph button. Now I hope that I see everything, but here's what I know. This is a full parabola, and this line went through it here, but this is why we did the beginning lessons in section 7, because I know that if I extend this graph way up here, this red line is going to cross it again. So I do have to change my window. Again, if I want to see more, I can always just go to the zoom button and number 3 to zoom out. Enter, enter. Okay, and so now I can kind of see that it crosses there. So you want to make sure you can see everything you need to. You could use zoom out. You can change manually by hand, just looking at the window as well. Okay, so I'm going to go to second, calculate. So that's where we find our intersection points, number 5. We did this earlier, this chapter, with some other stuff. My cursor's over here. It's probably going to give me this intersection point first, which is fine. I'm going to hit enter 3 times. And you can see that it tells me this point of intersection is 0.71, 1.88. Okay, so if I go back to this, I'm just going to write on here now. Okay, so we're looking at this graph. Oops, it's not even a graph, it's upside down. Okay, try again. Looks something like this. I got 0.71, 1.88. This is not my answer yet. I'm just keeping track of what I get on my calculator. Because now when I go second calculate again to get that other one, the first one's going to go away. Hit number 5. Now if I do it again, it's going to keep giving me the same point. So I have to remember, scroll my cursor towards that other point of intersection. Once I'm close to it, then I hit enter 3 times. And it gives me the other intersection, which is negative 12.71, 42.12. Okay, so come back here, negative 12.71, 42.12. Okay, but here's what we need to remember. The original problem was this. And in the original problem, I only have x's. There are not any y's. That means that my answers are just the x values. Okay, so I would say x, and we're going to use the approximately symbol, which is like a squiggly equal sign. We use approximately because it's not exact, negative 12.71, and my other answer would be 0.71. A lot of times Pearson will have you just type it in as 2 answers with a comma between it. All right, last but not least, I want you to try one on your own. Take this system, or take this equation, break it into a system, graph it on your calculator, and solve. Okay, so you should have under y1 graph 3x squared minus 7x plus 4. Under y2, you should have graphed 9 minus 2x. When you graphed it, it should have looked something like this. Again, this is just a very basic sketch. When you found the 2 points of intersection, the x values, again, all I care about is the x values, should have been negative 0.7, 2.37. If you didn't get those, go back, try graphing it again, and see how you do. Okay, so just to summarize, when we graph a system of linear quadratic equations, we could get no solutions. That's if they don't intersect. 1 solution if they intersect in 1 point, or 2 solutions if they cross in both. And then don't forget, when we're graphing inequalities, you are checking for solid or dotted, and then the final solution is where they intersect. And the picture is just the answer in the linear quadratics. All right, go ahead and start working on your Pearson practice for section 2.7, day 2.